Today, corporate employees expect and demand to be able to access corporate resources from anywhere. In fact, as we've alluded to in earlier CBT Nuggets in this series, they expect to be able to do this on whatever device they may possess at that moment. So this particular nugget is extremely important as we take a look at the major technologies and the major design aspects of the remote access modules. We'll go ahead and break this particular CBT nugget up into three main areas. First, we'll take a tour of some of the main WAN technologies that we're going to find popular today. We'll then talk about the Enterprise Wide Area Network module and the important Enterprise Branch Office module. So lots to do in this particular CBT nugget. Let's get started. Now, before we get deep and really focus on some specific WAN technologies, I just wanted to give you a sense for the complete and total diversity that we have here when it comes to potential WAN technology solutions. Long ago, we would do X.25, for example, or a replacement technology to that I would still consider legacy, and that's frame relay. These technologies would have what we call customer premise equipment running this particular frame relay packet switch technology between that CPE stuff and an internet service provider cloud. What was interesting about these packet switched technologies is that inside the internet service provider cloud, there might be some other technology running for WAN like ATM. Frame relay is considered packet switching. ATM is considered cell switching, and that's because they figured out how to take the information and divide it up into small fixed length cells. MPLS is hugely popular today in internet service provider clouds, and this is where we shim a little label. Yeah, the L stands for label. We shim a little label into the packet, and then we make forwarding decisions really easy and efficiently based on that label. Metro Ethernet is another WAN option. This is used in MANs. What in the world do I mean by MANs? Metropolitan area networks. So you might have one building in a city and another building in a city, and your corporation is lucky enough to own those two buildings, and you connect them with Ethernet. Yeah, amazing. So extending the length of Ethernet. Metro E is so exciting, of course, because everybody seems to understand Ethernet, and we can extend that high speed, easy to understand technology solution to more wide area network distances. Wireless could be deployed in the WAN environment. And then how about all that fiber optic that was laid in cities and even across oceans when the internet was absolutely booming with no sign of slowing down? Well, some of the fiber that's unused we call dark fiber, and that fiber is being claimed today in order to move data in the wide area network at very high rates of speed. So, isn't this interesting? I just did some brainstorming here and came up with a variety of WAN technologies, and this is just a very small sample. Now, one of the technologies that has gotten a lot of press is digital subscriber line, or DSL. Here I've sketched out a typical DSL environment. By the way, with WANs, we have something very important called a demarcation point. What is the demarcation point? It's really funny. It's where you're responsible for stuff and the internet service provider is responsible for stuff. Yeah, pretty important point, right, in the WAN infrastructure. So here we can see a PC. It's certainly customer premise equipment, and it attaches to a DSL modem. The fancy word for a DSL modem is an ADSL transmission unit remote, or ATUR type device. This ends up connecting to something that's on the service provider side of things, and it's called a DSLAM. The DSLAM is a DSL access multiplexer. So it's taking in a bunch of signals from a whole bunch of DSL subscribers. What does the DSLAM do? Well, it forwards the data into the service provider's cloud, where sure enough, any number of technologies might be going on. Now, let me give you a huge tip on digital subscriber line technologies. The thing about DSL technologies is there are very many flavors of DSL technologies, so please be aware of that. You'll be interested to know the distinction. You see, there is something we call symmetric DSL. Let me try and spell that right. Symmetric DSL. And then there is asymmetric DSL. Very important, the difference between these two technologies. With asymmetric DSL, we have a different speed for uploading than we do for downloading. This is the most common type of DSL. It's often referred to as residential DSL. So you've got really relatively fast downloading, but relatively slow uploading. Business class, as it's often marketed as, business class DSL is symmetric DSL. Sure enough, the uploading and downloading speeds are relatively equal, and they're both relatively fast. You can see how that would be more important in a business type utilization of DSL technology. Now, what about cable modems? What about accessing wide area networking information via a cable system? Yeah, well, this technology certainly became popular. In fact, one of the things that's interesting about this technology is that it was initially implemented as a shared bandwidth type of an approach in neighborhoods. So it got a really bad rap. In fact, DSL providers were running commercials that showed a bandwidth hog in the neighborhood. In fact, I remember one such commercial that was absolutely hilarious. All the kids were like throwing eggs at his house and spray painting his house. Bandwidth hog, you're ruining all of our other access to information because you're hogging our bandwidth. These days, cable manufacturers have figured out how to give quality of service for those that pay for it. So you can be guaranteed rates even if you're in the shared cable type of environment. What do we have going on? Well, we have a DMARC point, of course, and here you can see the customer premise equipment that includes a PC and a device they give us called a cable modem. By the way, you're running the point-to-point protocol, except you're running it over Ethernet in your CPE side. So it's pretty cool. You're running PPPoE in your environment. The cable modem connects up to the service provider's cable modem termination service. Yeah, the CMTS, or cable modem termination system, as they would refer to one of the specific devices. Now, something else that's interesting about all this is it's all falling under standards-based designs, of course. So another piece of terminology I want you to know is DOC, D-O-C, SIS. Yes, cable modem technology and cable signaling technology all falls under what is called the Data over Cable Service Interface specifications. So, when the service provider is shopping for their CMTS, when they are picking out your cable modem, when we are talking about the signaling between these devices, it is all specified in the DOCSIS standards. Now, one of the things that kind of plagues us in our industry is the fact that a simple term like wireless is just nowhere near descriptive enough. In fact, I could just imagine someone walking around some corporate party saying, "Yeah, I'm an expert in wireless." Well, I would quickly say to that individual, "Okay, now wait a minute. What do you mean by wireless?" Right off the top of my head, I can think of 3 different things that we could mean by wireless. Probably the first that most think of today is wireless local area networking. You know those standards like 802.11g or 802.11n. And by the way, you can capitalize those once they become official standards. Isn't that interesting? So 802.11g, lowercase g, is how we referred to it when it wasn't official. When it becomes official, you can uppercase the g. Pretty neat. But so with wireless, most of us think, oh, yeah, wireless local area networking. And we think about hopping on and accessing wide area networking when we are sitting at a local coffee shop. Insert your favorite coffee shop mentality right there, right? Okay. Now, what would be a second type of wireless? Well, what we call mobile wireless. In fact, for many people, this is what they would think of, right? Sure, they think about getting on their cell phone. Cell phones used to look like this, right? Flip phones. Actually, cell phones used to look like this. They were the huge bricks with a big rubber antenna. Now, of course, we know our cell phone is our PDA, our amazing little tablet device, our little miniature tablet that fits in our pocket. We're not here to talk about the evolution of cell phones, but we know they're going to operate thanks to wireless communications. And that's an entirely different set of technologies than wireless LAN. I mean, sure, we're sending data through the air and it's remarkable, but there's a different set of technologies involved. And then finally, a third area that I could think of right off the top of my head is what we call bridge wireless. This is where we have like a building and we go ahead and we set up equipment to send technically wide area networking information over to another building. So let's be careful today when we say that we're an expert at something. It may be that we need to really quantify that. For instance, I would consider myself pretty darn good in the area of wireless LANs and wireless bridging technology, but I am a newbie when it comes to the ins and outs of cellular wireless. Now, what about carrying data for the WAN over those fiber optic infrastructures that we know exist out there? Well, we have SONET and SDH that can do this. And please don't confuse sonnet with something William Shakespeare would compose. Okay, so we have sonnets and SDH. Sonnet is an ANSI specification, and SDH is kind of the equivalent specification, but it was proposed by the ITU. It's interesting because if you're in Europe, you'll typically see SDH used widely. If you're in Asia and the Pacific Rim, you would see SONET more frequently, for example. SONET and SDH often come up in discussions of topologies because SONET and SDH are example of dual ring topologies. Yeah, when you're studying topologies in networking, you first study the single ring type of topology that would be used in the legacy token ring. And everyone in class kind of groans because who wants to talk about something that's really dead like token ring? But then you get them all excited and you talk about a dual ring topology that might be found in SONET or SDH. This is guaranteed bandwidth technology, and it's called optical carrier rates that we use to talk about the speed that you just purchased. For instance, if you say, hey, I just went out and bought myself an OC1, that would be the equivalent of approximately 51 megabits per second. That probably wouldn't impress your friends much these days. But if you said, you know what, I just purchased an OC255, your friends might be a bit more impressed because you would have an approximate 13 gigabit per second technology. So we measure the speeds of our SONET or SDH in these optical carrier rates. Now, as far as getting IP over this particular optic technology, there are two ways to do it. There's ATM, so you use ATM to get the IP over the SONET or the SDH ring, or you can use what's called Packet over SONET or POS. So, two competing technologies there. So, when we want guaranteed bandwidth, when we want the automatic recovery of a dual ring topology, and when we want to put IP over the fiber optic WAN environment, SONET and SDH are more options for us. Now, it wouldn't really be fair of me to talk about SONET and SDH without doing two things with one stone here. And that is, number one, giving you an acronym that you can know and you'll sound really, really educated about WAN technologies, particularly optical WAN technologies. And then the other thing is you really should know about this because it is a key technology that SONET and SDH would use. It's called dense wavelength division multiplexing. Yeah, next time your boss taps you on the shoulder and says, "What are you working on?" just turn and say, "I'm working on dense wavelength division multiplexing." Look, what does the word multiplexing mean? Whenever we hear multiplexing, don't think about the cinema. Think about the fact that with multiplexing, we're talking about how to very efficiently get multiple signals on some type of media. Yes, this is used in SONET and SDH to really optimize the bandwidth usage of that technology. So when you hear dense wavelength division multiplexing, just realize it's a way to improve the utilization of data signals on that optical fiber. Now, I know what you're thinking. You're thinking, oh my goodness, there's so much variety here. How would I ever go about helping a company design their wide area networking? I mean, how would I possibly sort through all these options and come up with what's right for them? And then you have that light bulb moment. You go, oh, I know what Anthony's going to say. It's going to be all about the money. Show me the money and make sure I'm getting the correct WAN technology for an organization based on price. Well, keep in mind that this gets pretty complex too. For instance, is the price going to be just based on the particular, what we call access circuit that we are purchasing? And is this going to vary based on bandwidth available? Is it going to vary based on distance? Something else to think about is how long does it take to provision? So, in other words, if we pay the least expensive rate, is it going to take like 120 days for us to get our circuit? And how long are we stuck in this particular contract? Remember we talked about dark fiber? That's where you can go ahead and purchase a portion of the fiber infrastructure that was previously unused. Contracts for dark fiber literally are 20 years oftentimes. So yeah, the huge corporations that own that dark fiber say, yeah, you can have some, but you need to commit to us to use it for 20 years. So there is a lot that has to be thought of in this simple topic of price when it comes to the WAN. Remember the Alamo? No. Remember PPDIOO when it comes to designing your WAN for your particular client. Remember the methodology we discussed for that lifecycle model? We want to analyze the network requirements of the customer. Yeah, I mean, what kind of apps are they thinking about running? What type of bandwidth requirements? How much money do they have? How much expertise in these various areas do they have? Characterize their existing network, and then go ahead and design their wide area networking infrastructure based on things like the availability of technology for them, their projected traffic patterns, and the performance constraints and reliabilities that they experience. Now, there is just no way that I can talk about designing for the WAN with you, and we're still in that area, remember, of just technology. There's no way I can discuss this with you without getting into one of my favorite topics. And you might say, Anthony, now wait a minute, are you just doing this because it's one of your favorite topics? No, of course not. No, this is really something critical, and it's quality of service. Inevitably, you're going to have to deal with some aspect of quality of service in the WAN design, because you're not going to be able to completely over provision in that WAN design. Let me start there. You see, there are three overall approaches that you can take to quality of service in both the LAN and the WAN design. I'll list these three approaches over here. Approach number one, do nothing. Well, okay, wait a minute. Not really do nothing. What we mean by this is you over provision. That's right. You give the company so much horsepower, so much bandwidth, that they have to do absolutely nothing from a quality of service configuration perspective. Actually, what happens on most of the equipment is first in, first out congestion management. In other words, the very first packets that arrive at the interface are the very first packets to go out. So that's one approach we could take. The second approach, and this was really the first to be invented, is called integrated services, or INTServe. This was made possible by a protocol, I'm not kidding, called RSVP. That's right. Resources would literally phone ahead, if you will, and they would reserve bandwidth and services on the various devices in the path to make sure they got the quality that they deserved. That doesn't sound very scalable, and it's not. So today, the most popular approach to quality of service is differentiated services. What we do here is we classify and mark traffic, and then on a hop-by-hop basis through the network, we treat that traffic in a certain way. So when we go and we engage in the differentiated services approach, we first have an area of this called classification. Yeah, we will go ahead and make sure we classify important traffic from unimportant traffic. And then we'll engage in congestion management. We won't use first in, first out. We'll use something fancier like low latency queuing, which will allow us to prioritize certain packets over other packets when interfaces are congested. We'll use congestion avoidance. Yeah, congestion avoidance will literally, something called weighted red is used here. This is where we will literally toss away unimportant packets when we're starting to get congested to try and avoid congestion. There's link efficiency mechanisms. Link efficiency deals with things like compressing traffic. Yeah, compressing traffic so it takes up less bandwidth. And then an area that many of you have probably heard of, we can engage in shaping and policing. Shaping is kind and gentle. It says, you know what? We don't have enough bandwidth to send you right now, so we'll buffer you and we'll send you later. Policing is more brutal. Policing says, no bandwidth for you. Wait a minute, that sounds like a Jerry Seinfeld episode. Yeah, policing says, look, if there's not enough bandwidth to send you, we are absolutely taking that additional traffic you're trying to send and we are going to drop it. So notice the differentiated services approach. Boy, we could have an entire CBT Nugget series just on that particular differentiated services approach because it is so sophisticated. When you master the quality of service design, no matter what wide area networking technology you provision for your customer, you should be able to improve how it functions to meet the goals of that organization. So when we start to really design the enterprise WAN block, the first reminder I have for you is that you're going to do it in modules. Sure, the enterprise WAN module is a module in and of itself, but you're going to go ahead and break it down into submodules like we talked about. And one of those will be remote access. How does someone working from home right? How do they go ahead and access the WAN and the enterprise resources? So that remote access module is something that you're really going to focus on. Things that you want to do too when you're talking about the enterprise WAN is break things down into categories. All of the technologies that we discussed in this particular nugget, you can break down into the areas of leased line technologies, packet switched or cell switched technologies, circuit switched technologies, which we didn't really talk about, that would involve like the public switched telephone network, for instance. These tend to fade more and more from enterprise WAN infrastructures. And that new series of broadband technologies, this would include things like DSL and cable, where we are cleverly figuring out ways to send data over infrastructures that we had never anticipated sending data before. Think about it. We never in a million years were thinking about internet data traffic coming in over your cable television coaxial connection. So broadband is cleverly expanding the bandwidth or broadening the bandwidth that is available to us. Something else you think about is the WAN topologies that you are going to be interoperating with. For instance, if you have your enterprise and then a bunch of small branch offices, are you going to partially mesh them, for instance, in a popular hub and spoke type design, or are you going to try and fully mesh them, providing a direct connection from every node to every other node? So, we are going to design in modules. We are going to categorize the various technologies we're to use, and we're to think about exactly what type of WAN topologies we need to utilize. Now, another submodule of your WAN module that's hugely important today is the VPN submodule. Yeah, the virtual private network module. We know that we may have remote access type VPN connections. This is where someone from home connects to the corporate resources over the internet. Yeah, they use the public internet to make a secure connection. We might have what we call an intranet type VPN. This is for one branch office to communicate to headquarters. Notice it's stuff that's internal to our organization, but then we may have an extranet VPN. This is where we allow partners to securely connect to our headquarters, for instance, and access certain information. But perhaps one of the biggest concerns here with VPNs is who runs it, who manages it. For instance, is it the company or the enterprise? If so, they're probably going to use IPsec. They're going to set up the IPsec and manage it themselves between all these devices. By the way, if they have data that won't run over IPsec, like multicast, they'll use GRE over IPsec. Yeah, they'll put the multicast in a GRE tunnel, and then they'll go ahead and use IPsec for that. Cisco has an EasyVPN solution. What's funny about this is it's very complicated to set up, but then once you set it up, individuals can use your VPN equipment very seamlessly. So those are VPN technologies that the enterprise would be in charge of troubleshooting and managing. But what about the service provider just handling the VPN stuff for us? Well, great examples of this are MPLS. We talked about it earlier. Multi-protocol label switching VPNs are something that the service provider can just handle for us. How about that Metro E? Yeah, Metro Ethernet can provide our VPN services across town, and that's something the service provider will handle. And then another area called Virtual Private LAN Services, or VPLS. Now, what does VPLS do, you might ask? Well, it's a way in which that Ethernet type of technology can be sent over MPLS. Yeah, so you're literally bridging the Ethernet over the MPLS network as a way in which to do the WAN. And again, that's something that the service provider is going to handle and manage for you. Now, if you're engaged in a WAN design for an organization and they say, Anthony, our WAN implementation is absolutely critical, as you know, the WAN can never be down. We want better than 99.999% uptime. Well, you might say to them, look, we need a backup solution, and I want you to spend the money that's going to be required to have a permanent secondary WAN connection. That's right. It is up. It's established. It's sitting there doing nothing unless it needs to do something. And I mean, that obviously is going to give you an amazing solution in terms of high availability. A less expensive option is to do what's called a shadow PVC. Yeah, so we have this branch office, we have the corporate headquarters, there is this main PVC that we use all the time, and then there is one that can be provisioned really quickly in the event that it needs to be. Notice it's not always there. Yeah, it's just going to be a permanent virtual circuit that can be created. I chuckle because the word permanent isn't actually true there, is it? Yeah, it's permanent once it's up. It's just not always up. And then another solution that is even lower cost than anything we've mentioned so far would be to say, look, let's just do an on-demand IPsec tunnel when we need that redundancy. So we might have the branch office, and we might have headquarters, and we might have an ISP, we'll say ISP A, and we have this permanent way in which we get to headquarters via that connection. Then we might have ISP-B down here, a very low-cost internet connection, and bang, if we need to, we'll bring up a VPN tunnel across that alternate path. So, WAN backup, definitely something to think about if the organization needs it, and I'm sure you're not surprised we're going to have choices within that choice if we should implement it. Now, before we move and talk about the branch, let's just wrap up with some final thoughts on this WAN module and its submodules. Look, let's think about some major categories we have to worry about in the design. Scalability. How well does the WAN implementation we're thinking about designing, how well will it accommodate the inevitable, hopefully, the inevitable future growth of the organization? How about that availability? We talked about backup links and things of this nature to make sure it provides the WAN availability the company needs and expects. And how about the continuing operational expenses of the solution? How about the complexity of the solution? Can the organization handle that? Does it provide the appropriate voice and video support? How about the cost of the initial implementation? And finally, does the WAN solution support the network segmentation that an organization might desire? I mean, they might really shudder to think about a solution that you've designed where individuals can bring any device they want to the party at any location and access just about any information. So we have to look at the WAN design and realize, does it really provide the security type infrastructure that the company might desire? Well, this has certainly been a lengthy and complex CBT nugget that I really hope you've enjoyed. And I wrap it up by pointing out to you, your design efforts aren't done at the WAN because we're probably going to have to do branch office modules. Now, Cisco points out to us that we should come up with some method of categorization of the branch office. They suggest we start with a simple small, medium, large approach, like we're shopping for a pair of pants. Yeah, but 50 users, is that a small branch office? 100 users, is that a medium? 200 users, is that a large branch office? So that's probably a good starting point. And then we'll look at decision criteria when we're designing, like the overall number of locations, the number of devices in those locations, what scalability does each branch office might need, what availability on a branch office by branch office design. How about the security of the various branch offices? How easily do we need to remotely manage them? Do they need wireless? And of course, on a branch office by branch office basis, we have to think about the financial resources that we can attribute to that particular branch office design. So, one of the most complex areas of design by far we have seen in this CBT nugget, and it is indeed the WAN. Particularly, our discussion of designing for the wide area network centered around, first, the various WAN technologies that we're going to see. We said it might be a bit easy to be overwhelmed by the sheer number of technologies there are to choose from today. We then really focused on the enterprise wide area network design and the sub-modules that would go into it. And we wrapped up by talking about the fact that there are going to be branch offices that we need to design WAN solutions for. Well, I hope this has been informative for you, and I'd like to thank you for viewing.